Teaching our students critical thinking and problem-solving skills, we're at the forefront of the worldwide Hour of Code movement. HISD students and teachers participated in the global activity designed to spark an interest in coding. Here's a look at Fawnville Middle School's Hour of Code.
Today our students are working with the Hour of Code, which is a worldwide event, and they will be writing their first JavaScript lines of code and learning how to do computer programming. This is important because they use technology every day, and we want them to be not only the expert users of technology, but we want them to create products. We want them to be innovators. The way we kind of bring it down to their educational level is using the drag and drop method, in which instead of typing all the coding, they develop their computational thinking skills by dragging and dropping the codes.
You have to try to get the avatar to get to the flower, so you would have to move it forward.
It's games that we've played before, but it's behind it, like you're actually making the game yourself.
You did 3 puzzles already? We want them to develop their skills and be able to work with other team members, developing and finding solutions for problems. They are engaged on writing code, but they actually sometimes don't even realize that they are writing code because it's more like a video game.
Joining me is HISD's Manager of Innovative Projects, Erica Dinkins, South Maid Elementary's Principal, Sandra Cisneros, and Bel Air High School's AP Physics teacher, Jimmy Newland. Erica, what kind of feedback have you heard from the schools about the Hour of Code activity? I mean, when you think about coding, you envision long JavaScript and backslashes and colons and long mathematical equations. Is it hard to learn?
No. In fact, we had over 140 campuses in HISD participate in Hour of Code, so we had an overwhelming response. And I think part of that is that Code.org's Hour of Code module is actually very approachable. So if you look at it, you might think that students are playing a game, but in reality they're engaging and learning the fundamentals of computer science through block programming. So block programming is a visual drag and drop computer language, and it's a great place to start not only for beginners but also especially our pre-readers.
Sandra, how did your students work during the Hour of Code? What did they learn from it? Were they excited? Tell me a little bit about their experience.
Definitely. You know, we have pre-K through 5th grade students participating in it, and our 5th graders were using the Angry Birds and the Frozen, and they were, you know, building commands and telling the computer what to do as opposed to the computer telling them what to do. And then for our younger kids, they were doing unplugged activities in which, you know, they're not on the computer, but they're using stackable cups to figure out what's the best way to stack these cups and bring them down. So they're using their problem-solving skills and they're being creative and getting creative in their ideas of which way to go with this. We also had our students in music class. You know, they played a song for them, and they had to figure out the notes that was in the song. So they used all kinds of different activities in order to develop these coding skills.
Oh, that's great. It seems so dynamic. Jimmy, were you able to use the Hour of Code in your AP Computer Science class?
I used the Hour of Code in all 3 of my classes.
Wow.
And I used the Frozen stuff. I sat down as a not young person, and I tried the different modules, and I thought, which would they like? And I tried the Frozen one, and I thought, this isn't going to be any good. And when I finished it, when I realized I had finished it and enjoyed it, I thought this is what I would try. And it did not matter what kind of kid was sitting in front of Anna and Elsa, they all loved it. At the end, they ended up printing very silly messages that I was able to put on my board, and I felt, you know, it was really great to have an actual product at the end of this that they were thrilled to do. And these are some very proud, cool teenagers who, you know, may not admit to loving Frozen. I even played some music.
Wow.
They were singing along. It was great.
That's fantastic. So can you tell me a little bit more about some of the interesting experiments your students are doing and how they're able to blend physics and computers?
That actually is, I feel like, one of the most important parts of the way physics should be taught. It's my own opinion on this, but I feel like if you can't think about algorithmically how the physics is doing its stuff, how we model data, why we model data, how does that tell us stuff, then I'm only teaching them if all they're doing are equations and all they're doing are problems. They're missing part of the actual science that gets it done. So we did a really cool thing where they actually took Portal 2, which is a video game, and Valve gave educational licenses to the school, and the students were able to make their own little game level, but it had to demonstrate some kind of physics. Sometimes the physics was silly, and sometimes it was great, but I made them talk me through it. So I went behind them with my iPhone, and they spent about 30 seconds explaining the level, and I had a couple of people who said, we have to do that over. I didn't say that. I wasn't smart enough. But that was really fantastic because some of them had never played the game, some of them knew it very well. And at first I'm thinking, is this going to devolve into gameplay? It was fantastic. They ended up, they worked in small groups and they made levels that demonstrated or either demonstrated good physics or showed how the game didn't do it. And I thought, this is what we need to be doing. They can look at something that, that doesn't have physics in it necessarily. They don't think about it that way and they're like, wait, this is doing that. This is velocity, acceleration. Air drag. It's not supposed to do that, and that felt really good. So it was really, really cool.
So can I ask you a quick question in relation to that? How does math and physics and computer science, how are they all related? For those in the audience that may not know.
So math, this is again my opinion, but I'm going to say it anyway. Math is one of the most important connecting tools in all of the STEM fields. The more math, the better. The earlier, the better. Can't go wrong doing math. Therefore, in all of the ways that computer science can look and feel like math, I do that. And it turns out that that's not hard at all. Yeah. Computers handle real world data by faking it with very clever math. So you have to understand the math. If you're going to make the computer obey your will, you've got to understand the math. And that's true for adults and kids as well. And that goes for physics or chemistry or biology or video production or anything else. You can't get away from computing in the modern world. So being able to control it and understand it gives you the power.
That's fantastic. Erica, I know that we're just at the beginning and we're forming a partnership with Code.org. What will this initiative mean for us district-wide?
So ultimately, we want to equip our students to be able to thrive in tomorrow's society. So young people need to learn to not only utilize the digital technologies out there, but we want them to be able to create with them. So we want them to take a more active role. And basically, we're building on the momentum already created through Hour of Code. With this partnership with Code.org, our goal is to expand coding and computer programming opportunity access to all students in HISD over the next 3 years. And that partnership with Code.org is just step one in that.
So what are the goals for the elementary, middle, and high school level more specifically?
So for elementary, it's really just, initially, it's just creating some kind of energy and just kind of opening up some of those Code.org K-5 Code Studio modules to elementary campuses. We're starting with a set of cohort campuses. We're shooting for at least 50 elementary campuses. Currently, we already have 60 that are interested, which is fantastic. Wow. We're going to do 20 middle schools and 20 high schools to start as well. And so that's for cohort 1, so that's next school year. So we'll begin some professional development with those campuses this spring as well as in the summer. And the goal is to kind of start these different code modules. So with middle school, it's more of a math and science integrated. There's Project Guts and then Bootstrap are the two that we'll be utilizing in middle school. And then in high school, we're starting with fundamentals of computer science. And then we'll also, once that's built and established at high schools, we'll move towards AP Computer Science, also supported.
Wow. So Sandra, you're the principal at South Maid Elementary. Coding combines creativity and logic. What types of projects are your students currently working on?
Well, we had a couple of volunteers from ExxonMobil come out, and so they really helped them with the programming once we were doing the Hour of Code. So we're also a STEM school, and so we're having them work on, we're doing robotics, and so we're going to open it up for them to actually command the robots and you know, go forward, go backwards. They do Like I said, they do the unplug activities in which they're, for the lower grades, in which they're, still using their problem-solving techniques with these activities, and it goes into also with reading and with math. I mean, we're trying to get them to be problem solvers, and so if they look at this and like, well, I can do it this way or I can do it this way. It's not one exact answer. Yeah. It could be a variety of answers for them.
Asking multiple questions,
yes.
Looking at things from all different sorts of angles. That's exciting. So, Jimmy, do you feel that your students how does this challenge them with learning how technology works and applying what they're learning in their classrooms to the specific projects that they're working on?
It's a challenge for them. We use the term digital native rather loosely, and one important aspect of having a city full of digital natives at our schools is, although they can make the technology do what they want, there are a lot of times that they don't know how it works. And many times I find that in computer science, you expose them to that ignorance, and they're like, I didn't know that. How did it do that? Why does it do that? And the more times you can connect that to social networking or news or hacking or anything like that, the more that you can see that the things they're using every day that they think they're so good with, they just don't really understand them all that well. So the more that I can do that, the better. And as a matter of fact, what you want to do, I feel like, in any kind of school situation is say, this is what you're doing in your real life. Here's how your phone works, here's how your home computer works, how it doesn't work, and what you need to be worrying about, and how you are living your life in a digital way. And you can do that with computer science.
I had a wonderful opportunity to meet Joseph Teran, who is a professor at UCLA, who helped with the mathematics for the programs that are used in the movie Frozen, specifically for snow. And he talked about the difficulty in creating those algorithms and the different types of math behind it. And my sister told me it's interesting that she's an artist, and she says, I benefit from the math and science that those folks create so we can make beautiful things for people in the community. And so this just shows how math, science, art, humanities, it's all connected and it's all interrelated. There was a statistic that I was surprised by, that in 1986 there were more women seeking degrees in computer science than there are today. What are your thoughts on how these programs can change that and turn it around?
This is in the computer science education community, this is an ongoing discussion. So the biggest problems in the world need computer solutions, and if we're only pushing, or if we're only allowing the men to answer our questions, we're missing a lot of the really smart people. So we should be, anything we could possibly do to encourage women to do computer science is something that should happen, and Code.org is on board with that. So when teachers are looking for a curriculum or tools they can use in their classroom, here's one they can go to that's ready-made, that will work on the web, that has that major theme built into it. And my personal experience is that women in my classroom, they definitely like the Code.org stuff as much as the boys like it, and it's something we should all be trying, in your classroom if you can, use the Code.org stuff. Just try to find a place to put it. Yeah. You'd be surprised.
That's so important and key to incorporate it into the learning environment. And Sandra, you mentioned that it's important to get the students interested early on.
Yes. So, you know, whenever we look at the job opportunities that are out there, there's so many positions available. There's so many vacancies right now for engineers. And so, you know, if we're developing this pilot program, you know, we foster that love for computer science at an early age in elementary. We continue it in middle school and into high school. And then we can get these kids to really, that could be one of their majors that they can study in college. And so if we have, you know, our female teachers just excited about this computer science and programming, then we can really get our students, our female students, excited and moving into that direction.
Erica, what can families do to support the coding initiative in HISD?
Well, the great thing about Code.org, and one of the other reasons why it's a great place to start with that partnership, is that Families can sign up for their own free accounts at home. So if a student has an account at school, they can actually log in at home as well to any of those interactive tutorials online. And there are also tons of free apps available. So if you have a kid who's engaged in that smartphone or that tablet when they get home, and that would be a great place for them to start as well. So with the Tinker app, for example, or with the Scratch Junior app, there's tons more beyond that, but that would be a great place to start.
I was looking at the bottom of your thing. You have something that says code?
I do. I have I have a code.org clipboard.
That's awesome. Well, thank you so much. I really enjoyed spending time with you today, and this is extraordinarily exciting. Great for our students.
Absolutely.
And thank you for all of your hard work as well.